For this simple example we will look at how we go about our daily lives and represent this as a search space. So let's imagine a normal day. We take some typical activities that we do in a normal day, like having breakfast, reading a book, playing computer games, watching TV. Tomorrow is another day. We might start the day with breakfast, then attend a lecture. Obviously each day is different. There may be similarities between days, because we are creatures of habit. But it's safe to say that each day is unique from all the others. Given these multiple possibilities in a day, this uniqueness, how can we represent all these possibilities? The endless ways of what we can do in a day. How can we represent this information in a meaningful way? We can consider a space of all possibilities, all activities that we can do in a day. This is an abstract model that allows us to think and see patterns in the endless possibilities of what we can do in our lives. It allows us to represent a real-world issue in a more abstract way. How can we construct this space? Let's take a single day as an example. We select each activity that we do during that day, like attending a lecture. And this is the trick part. We have to map this to a dimension in our state space. One side of the space. Since we like working with numbers, we keep track of the time taken for the activity attending a lecture, and mark this on our dimension for this activity. It's 3 hours in this case. We do the same for the next activity. We create a new dimension in our space called reading a book. Since we spent only 1 hour reading a book, we place our mark at 1 on this dimension. We do the same for the time spent watching TV. We spent 3 hours watching TV. Note that the marks we place on each dimensions eventually intersect at a single point in our space. Since we can do a lot of stuff in our daily lives, we can have many more dimensions. One dimension for the activity spent training in a gym, one dimension for playing computer games, studying, etc. So as one can see, this space can have many dimensions, making it quite large and complex. But regardless of how many activities we do in one day, that day can always be mapped to a single point in this space. If we didn't do some activity that day, we can always set it to 0. And for those activities that we do, we mark the hours we spent doing them. Another tricky part now. We have seen how we can take a day and map this day to a point in this space, but the reverse is also true. We can take any point at random in the space, and this point gives us a sequence of activities that we can do in a day. One can think of it as a plan or an agenda for our day. And this is quite a powerful idea. Our space has become an abstract model of our daily lives. We can move back and forth between our days expressed as a list of activities and this abstract model, the state space. Points in this space represent days we have lived, we have experienced, and days we have yet to live, or could potentially experience. In computer speak, this space is called a state space, because you can only do one activity at a time. Be in only one state at a particular time. For example, can't read a book while watching TV. So, okay, we created the state space to model our daily lives. But why all this hassle of constructing this space? What's the advantage? Well, one thing we can do is to look for patterns within it. In this space there will be a cluster, for example, of points with high values along the dimension playing computer games. These points represent days where we have played computer games all day long. There will be a cluster of points for days where we spent most of the time watching TV. And points in between where our days were divided equally between playing games and watching TV, etc. And in the center of this space, we can find balanced days, days where we did a lot of everything. The state space allows us to answer questions such as, finding good days. But what do we mean by a good day? Or fruitful day? It could mean the most productive day, the most balanced day, the most restful day, or a good holiday, or a productive study day. A search space allows us to answer all these questions, as long as we can design some form of measure, to compare different days. As a simple example, we might consider a good study day to be one in which we studied for 3 hours or more. And we apply our measure, our ruler, to all points in our space, and find the best point, which in turn gives us a plan, an agenda, for a good study day. In AI speak, this measure is called an evaluation function. Remember that the points in this space can represent both actual days that we have lived, as well as potential days that we can ever experience. And this last thing can be quite large. The combinations of all possible activities that we can do in a day is quite massive. In fact, this space is so huge, so massively huge, that it is practically infinite in size. And this brings us to the main problem. How can we ever possibly try to search for a good study day in this massive space? How can a computer program, using our evaluation function, hope to manage to check each and every point, each and every potential day, in this nearly infinite space? Fast as it might be, our program will only manage to check a tiny microscopic part of our state space before the lifetime of the universe runs out. The only hope is to put some form of intelligence in our program. Instead of searching blindly each and every point, we apply some shortcut, some trick, in order to try and check only those points that are most promising, in the limited time we have available. Our shortcuts or tricks are not guaranteed to work every time. But we have various tricks up our sleeves, that we can use. And that's what all the different algorithms in AI do. They each apply a different trick, shortcut, or heuristic, to explore and search a state space. So, essentially, all AI algorithms are just different ways of wandering around, in a state space, hopefully in a slightly intelligent way, in the hope of finding a good answer. In AI speak, the trick or shortcut used by an algorithm is called a heuristic. So, in a nutshell, this is the whole story of AI. Given a complex real-world problem, we represent or model this problem as a state space, and then search this vast space in an intelligent way, using one of the tools available in our AI toolbox. This approach will be followed regardless of the type of problem we are trying to solve. Be it finding the best order of lessons while planning a timetable, predicting the stock market, recommending music or books to an online shopper based on what she has already bought, or developing a self-driving car.